All right, so let's talk matrices. So if you're in your book, I don't know exactly what page is this, maybe 25-ish, I don't know, it changes from year to year. You look in your book, at the first page on matrices, I want to talk about where these matrices are actually coming from. Okay, so when you have a system of equations, and matrices aren't that old actually. In the last couple hundred years, mathematicians came up with the whole idea of matrices, and it's really pattern-based. But and we talked about Gaussian elimination last chapter. Gauss did a lot with matrices. There's plenty of other guys. This guy, last name Jordan, I think, did a lot with matrices. And determinants, which are kind of go along with matrices. We'll talk a lot about determinants and remind you about what we learned last year. Inverses, all that stuff that we learned. It was just pattern-based math with systems of equations. And the great thing about this is back when they invented all this, there were no computers. And it was just a very organized, systematic way of getting stuff solved. And there are better methods that we have, like substitution, when you're dealing with systems with just like A and B. But as you will see in this chapter, what this has allowed us to do, what matrices have allowed us to do, is take huge systems with like A, B, C, D, E, F, G, and organize them in a way, and our calculator, even though when you have that calculator or computer, can actually transform these into different forms, kind of like you did with Gaussian elimination. By putting those zeros in that corner, it enabled your variables to be exposed one after the other, and your calculator can do all of that. So I want to talk about some of the language of this, and then we'll just kind of get to, I'll probably review one of the Gaussian elimination problems we did, but we're going to do it now, not as a system, but as a matrix, one matrix to the other, but I really want to make sure you can use your calculator well. Okay, so first thing is I want to talk about what an augmented matrix is. So an augmented matrix, right here, is a way to write a system as a matrix. Okay, it's nothing fancy at all, but literally all I am doing, the first thing I'm doing is I'm making sure that my variables show up in a certain order. Okay, so I like to, have alphabetically like X's, then Y's, then constants, or A's, then B's, then C's, then constants. And you just bring down the numbers. And some books, and I think yours may do this, sometimes they put this little dotted line right here, this little vertical dotted thing right there to I think it's to kind of suggest to you, hey, these represent the coefficients of the variables and these are just the constants. But I don't care if you have those or not. All right, so something like this, if I was forming the augmented matrix for this one, again, you need X's and Y's and zeros in that order. So the augmented matrix here, because I have an X, a Y, and a Z, I'm going to need a space for the X, Y, Z, and the constant. So there is no X term in that first one, so I need a 0. But then the Y is 1, the Z is -3, and the constant is 5. And again, if you want to put that dotted line in there, you're welcome to. On the second one, the X value is a 2. There is no Y, and the Z is a 1, constant -1. And the third one, the X is a 4, the Y is a -1, the Z is a 0, and the constant's a 0. This is arguably one of the top 3 questions that are missed on this test. I'll give a problem that's just missing some variables, and people will not rewrite it as a 3x4 matrix. They'll write it as a 3x3 and just put 1, -3, 5, 2, 1, -1. I'm not kidding. That right there is probably one of the top 3 missed questions on the test every year. So please be careful about that. Remember, augmented matrices, you need a column for each variable. You can't have Y's and X's together or Z's and Y's together. You can't have that. All right? Pretty good so far? Oh, while I'm at it, I want to talk about what a coefficient matrix is. Anybody got a guess if that's an augmented matrix, what a coefficient matrix is? Take a guess, be a hero.
Is it just the coefficient?
Not a coefficient of the matrix, but it's just the coefficients in a matrix. So what's not a coefficient? The 12 and the 16. So you wouldn't have a dotted line, you would just have that. Okay? And we could actually, this is called a coefficient matrix. So over here, the coefficient matrix would be just that. And you can use a coefficient matrix to also, as you're going to use the augmented to solve, because this, think about it, times x, times, I could use that, but this would be better, times xy is 1216. Do you see that this is true? Because how do I multiply a matrix times a matrix? Do y'all remember that from Algebra 2? You take the rows of this one and multiply by the columns of this one at a time. And if this is a 2 by 2 and this is a 2 by 1, I can multiply them, right? And what do I end up with? A 2 by 1, which that is a 2 by 1. So I can do it. Now check it out. This one right here is going to end up being a 2 by 1, and I'll compare it to this. But check it out. Row times column would give me 2x minus 3y. Row times column would give me x plus y. So this matrix is equal to this matrix. But guess what? That's what I have, isn't it? So you can rewrite this with a coefficient matrix times an xy equal to 1216, or even better, we can use, I think better, we can use, because this didn't really help me to solve, it just kind of rewrote it that way. But do you remember how to solve something like this? If I wanted to solve for x and y, do you remember what I could do? How do I get rid of that? Do what? I would love to be able to divide it, but there's no division of matrices. So what do I? You know how, like, if I had this, something like this, you would want to divide by 2. But another option is to multiply by inverse, a multiplicative inverse, which is like a reciprocal. So what is the problem with matrices? Multiplying by 1/2 here works great. But I use the commutative property. I said 1/2 times that equals that times 1/2. That's like saying A times B equals B times A. Does the commutative property work with matrices? You might remember that. It does not. So if I want to get rid of this, I multiply by its inverse. And I would put an inverse on this side. And when I multiply it out, it kind of like gives me the number 1. Except that number isn't the number 1. It's the identity matrix that has 1s with 0s. We'll go over this in a second. But there are going to be multiple options you have to solve and that you'll have to show me when you're taking the test. And I'll detail all of those. But if I multiply by the inverse over here, can I put it over here? It'd be so easy though, because I don't have to rewrite the problem. No, we can't do it. Because doing this is great when I'm solving equations, because you have something called the commutative property. It doesn't work with matrices. So you have to actually find a way to squeeze that inverse in there. And we'll talk about inverses. And yes, all of this will go away, and you'll get a new answer right here, and you'll be happy, and everybody will move along. But right now, we're going to put this on hold and keep plugging away with this row echelon form that I'm about to introduce. Okay, so far we've got augmented. Now I want to talk about row echelon form. Now, row echelon form is a little different than reduced row echelon form. This would be an example of reduced row echelon form. I'll tell you, we'll just go one at a time. Row echelon form. All right. Oh, I put it right here. Row echelon form is a form that's kind of like what we did with Gaussian elimination. Row echelon form wants you to have something x up here, and that stood for the x equation, remember? If this is an augmented matrix, this stands for a matrix that has like x's, y's, z's, and constants. And we said in Gaussian elimination, I wanted to have that value there. But I didn't want to have a value here, and I didn't want to have one here or here. Okay? Well, row echelon form makes this get to here, and I don't know exactly what the numbers are, because I haven't actually done the math on it. You're going to have some numbers here when you finish up, right? You'll get it down to this point. Well, row echelon, technically, okay? Technically, these numbers need to be 1. So if I did get down to this, and this had like a 3 there, and a 4 there, and a -2 here, what would I need to do to technically make it row echelon form? Divide by 3, divide by 4, divide by -2. But I'm not going to ask you to do that when you're doing it manually, because what do you think happens as soon as I divide by 3, 4, and -2? What do you think happens a lot to these other numbers? You end up getting fractions, which aren't bad or illegal, but they're just a little bit more annoying when it comes to the solving process. So what we're going to do manually, in our row echelon, we're just going to kind of do our version of it, and we're going to basically stick with what Gaussian elimination does and just focus on the 3 zeros. Because it's pretty easy at this point to solve for that value here and to plug it back in and solve for that value here. But you got to remember, this is a matrix, but every one of these terms stands for a coefficient with its variable. So this is like an x term. This represents 3x. These represent something y, and these represent something z. Are you with me? So in order for us to get there, we would have to do the Gaussian elimination process, which I'll do, but I want to show you your calculator first. So go to your calculator, turn that guy on. Everybody with me? Mine's rebooting. Look at this sweet time. It's not my day. We are in the 50s though, in days to spring break. So that's a positive. Okay, so once you're on this, I want you to go Okay, so I want you to go and get on a free spot. Can everybody see this? Okay, and you're going to go to, you see where you see the book button? Where you see the book button, to the left, if you click the left side of that, not the actual book, but the other part of it, if you click on that, you'll see that there's an option for a matrix. Are you with me? Now, these options for a matrix, that's specifically a 3x3. So if I hit, oh no it's not. If you hit the one that says 3x3, it gives you the option to pick and define it the way you want. And I want a 3x4, right? So I'm gonna have 3 rows and I wanna have 4 columns. So hit 3, 4, and then okay, and it'll give you this.
Wait, which button did you?
Okay, this one right here where it says a book, I wanna click the left side of it, okay? All right, so now I can enter anything I want. So on number 3, I'm going to enter 3, and the best way to do it, I believe, is to tab 6, tab -2, tab 28, and if you just tab along. It'll get you all these values. Now once the matrix in there, and you can do this ahead of time if you want, if you go over to the very far left, and there are other places, but my mind's kind of freezing up on me right now, to find this stuff. If you go to the actual book and hit enter on book, if you hit the actual book part, the right part, you'll see a list of every function on this calculator. Okay, and if you want to jump to a certain function, like if you wanted to do a determinant, hit the letter D and you jump to the D's, and you could come down and in a couple seconds out in alphabetical order. Oh, there's a determinant. So if I wanted to take a determinant of something, there it is. And again, this stuff is in other places on your calculator too. Well, I want to do row echelon form. So I'm going to hit R, and it's going to jump to R's, and I'm looking for REF. There it is, REF. So for me to do this, I go book, REF, and I want to do that in front of this. So I'm going to get on the left side of it, and I hope this doesn't mess me up, or I'm going to have to type this in again. So book, REF, it did.
You can just delete that.
Can I? Oh yeah. Oh, perfect. So just delete the right side of it, and it puts it on puts it automatically over here. So watch the magic here. This is beautiful. This thing's going to do the Gaussian elimination for me, but it's actually going to go one step further because it's going to throw ones in there. So I hit enter, bam. Okay. Now mine did it rounded to 5 decimals. So if you start doing really big systems, it's going to be hard to see it all. So if you want to change the number of decimals, or also check this out, you could go menu. You could go up there to your gear, and you could say dock settings, and I could change this from fix 5 to like fix 3, or even fix 2, whatever, and hit enter. And it could reduce it so you can see it better. Or also you can click and highlight it, like I'm doing right here. If I click on it and hit enter, so I'm highlighting it, and then go menu, number, approximate to a fraction, it'll change it to fractions for you. Let me show you that again. So if it's in decimals, go grab it or hit second answer, hit enter so you drag it down, and then go, you can see it right here, hit menu, number, approximate to a fraction. If it's already in a fraction, then your calculator is set so that you are in, when you go to dock settings, you are not in approximate mode, you are probably in auto mode. And that's fine, but I normally like to see decimals, so I leave mine in approximate mode.
Oh, okay.
So if you already are in auto mode, great. But anyway, what this means, if you look at it, this is a situation where you got all zeros on the bottom. What did that tell you about this augmented matrix? Remember, it represents a system of equations. What does that mean? There's an infinite number of answers, aren't there? Right? Now, if I got 0, 0, 0, 4, then that would mean no solution. Or if I ended up with a 1 there and a 1 there, because remember, row echelon form has 1s, then that would mean that I was already ready to start the back substitution process. Now, it's really, I probably shouldn't have done this on the very initial one, but for me to solve now, I would say, well, let z equal z. And remember, this stands for, actually, z equals -5. This is going to be a little weirder than this. So this one's going to be a little bit uglier than what we're used to. I probably wouldn't give you something like this on the test. But I get z equals -5, which I could plug in here. And I could actually rewrite this in terms of y. But it would be harder for me to do a problem like this than probably our pay grade. I really didn't mean to do this ugly. So let me give you something else. I'm going to go back up there and grab that original one right here. I'm just going to change the number. This is probably going to give me terrible answers. Yeah. Nope. That's a null set. Well, I'm all over the place here. Let me just keep playing with them. Surely they cross somewhere. Okay, this is more likely what you would do. You get this system, you type it in, you do row echelon form, and look at leading ones. Are you seeing that? 3 zeros and leading ones. But you can see by making them all ones, I turned all these other numbers into a mess of fractions. Are you with me? If I had just done Gaussian elimination the way I know how to do it, I wouldn't have any fractions in the problem. All right, because you'd always be subtracting and adding whole numbers. So the math would be a little bit easier moving forward. But you can see all those ugly decimals just because I'm making up the problem. But this is typical, and the rules for row echelon form is each row leads with a 1. Okay? Leads with a 1, leads with a 1, leads with a 1. And if there is one solution, you'll have 3 zeros like you did when we did Gauss. Yep.
So why on the first one didn't it go 1 diagonally?
It doesn't have to be diagonal. That's not a rule. That's a common result. But remember, the rule is leading ones.
Okay.
So if you look back through the other examples that we had, all these results did have leading ones, right? I led with a 1, I led with a 1, and this one actually ended with a 1, right? So I had leading ones in each row. Look at this other one. Leading ones. Led with a 1, led with a 1. But the goal again is to make these 3 zeros. If you get more than those zeros, you just got more information, right? You either got a null set, you got an infinitely many solutions, so you have a line that's a system, all kinds of things. What you would be required to do at that point is not something ugly like that where you got all those 4 zeros, but you would be required to know basically how to solve like you did before. But if I say put it in row echelon form, this is how you would do it with your calculator. Now there's an even better form than row echelon, and it's called reduced row echelon. And reduced row echelon goes one step further, and this one's really money. Okay? So on row echelon, you get down to here and you're like, great, I've got Z. 1Z is that. And if I know Z, what could I now do with Z? Go back and plug it into this, because this is technically negative 1.944Z. So I would take that, plug it in there, move that constant over, and I could solve for Y. Or I'd have Y, because Y is already a coefficient. And then once I have that, a Y and Z, what would I do? Plug them back into the top equation, because remember, this means 1x plus 1/2 Y, so I plug the Y value in there, plus 2.250Z, plug the Z value in there, move all that junk over. Well, reduced row echelon form, its rule is I'm going to have leading ones, and each one is going to have zeros above and below it. So check out what it does. Reduced row echelon form, and there's a button for it also, but I think you could just put an extra R in there. It's also in its RREF. Look what it does. It does leading ones just like row echelon form, but because it has zeros above and below, you're done. What's Z? 10.545. What's Y? 33.227. What's X? Negative 50.091. So it literally solves for you. So if you have a system of equations like we've been dealing with ABC or XYZ from here on out, and you are just working along, unless I'm going to be testing you on the actual math process, plug it in your calculator and knock it out. I mean, and this could be true for not just X, Y, and Z, but variables. I mean, a system of equations, you could have 5 or 6 variables in there, which we're going to do a couple of them. Are y'all track with me? Okay. So anyway, tonight, flip over to number 9 on the next page. So on number 9 on the next page, you can see we have this big Gaussian system here, right? So if I wanted to, I could set up a matrix. Check it out. I'm going to go in here, and I'm going to go left side of the book button, up to 3x3 matrix, enter. And this time I want a 4x5. And by the way, I'm not always going to be so kind as to leave open spaces there. Sometimes I just pack it all in together. So again, make sure all your X's, all your Y's, all your Z's, one column at a time. But check it out. I'm going to do a 4 by 5. And I'm going to start entering these numbers. 1, tab 2, tab 0, 0, 1. Look how easy this is going to be. 3, 8, 0, 5, 0, 1, 4, 3, 10, negative 1, 1, 0, negative 3, 0, negative 1. And I'm going to go to the front and check it out. Real quick. Book. RREF should be on there somewhere. Check it out. Delete, enter, bam. Ooh, look how easy that was. So I get all the ones. That's my what? That's my W, that's my Z, that's my Y, that's my X. Hey guys, if you see a problem tonight about determining the equation of a parabola or whatever, using all this, skip it because we didn't get to it.
I blame password.